Assalamualaikum and hi everyone, welcome back to my channel. So, macam mana persediaan final exam? Okay, sudah bersedia ke belum? Jadi hari ini kita nak discuss satu lagi set soalan, iaitu set soalan yang ketiga. Okay, so apa tunggu lagi? Jom kita mula. Okay, so let's continue question number 8A. So we have 50 gram mass is attached to a spring and it is set to perform simple harmonic motion with amplitude 12 cm and the period of oscillation 1.7 second. Okay, so instead we have a mass here which is 0.05 kg, and given that the amplitude of the oscillation is 0.12 meter, and then we have the T is 1.7 second. Okay, so now question 8A1. So now we want to calculate what is the maximum speed and acceleration of the mass. Okay, we want to find. Okay, so we have equation of the maximum speed is equal to A omega. Alright. And then maximum acceleration we can calculate by using negative omega squared y. Okay, so here we have two equations. Okay, V maximum and A maximum. Alright, so now we can calculate omega, since we know that omega is equal to, omega is equal to 2 pi over t. So here we can straightly substitute in this equation where A is equal to 0.12 and omega, or we can calculate omega separately. Okay, so omega is equal to 2 pi over t, where 2 pi over 1.7, so omega is equal to 3.696 radian per second. Then we can straightly substitute here. Omega is equal to 3.696. Okay, and then V maximum is equal to 0.444 meter per second. So this is the answer. How about the maximum acceleration? Okay, so we have omega here, negative 3.696 squared, while y, what is y here? Okay, so remember, okay, when y is equal to positive or negative a, which is the maximum displacement, which is amplitude. So remember, okay, at maximum displacement, okay, a is maximum. Okay, remember, at maximum displacement, which is y equal to positive or negative a, then the acceleration will be maximum. Okay, so you can see here, okay, remember our pendulum. Okay, let's say we have a pendulum here, where here, see, this is the equilibrium position and this is the maximum. This is positive a and this is negative a. So y is equal to negative a, y is equal to 0, and here is y is equal to positive a. Okay, so now as we know, at maximum displacement, when y is equal to positive a, so v is equal to 0. Okay, so at maximum displacement, v is equal to 0. Same goes to this one. But at y is equal to 0, here v is maximum. Okay, you must remember. Okay, and at maximum displacement, when y is equal to positive a or negative a, okay, so here acceleration is equal to maximum, and here is equal to 0, and here is maximum. Okay, so you must know this condition. Okay, and now we can straightly calculate. Okay, negative 3.696 squared. Alright, and y is the maximum displacement, which is the amplitude, is 0.12. Okay, so acceleration, okay, we can take it y is equal to, so negative or positive a, okay, and we can take the positive value. A maximum is 1.64 meter per second squared. Okay, so negative sign is for the direction. Okay, so we want the magnitude. So magnitude of the maximum acceleration is 1.64 meter per second squared. Okay, alright, so second, we want to calculate the speed of the mass when the displacement is 6 centimeter. Okay, so here we want to calculate the speed of the mass when the displacement y is equal to 0.06 meter. Okay, so remember. Okay, so remember, okay, we have two equations of v in terms of t and in terms of y. So when in terms of t, we have, okay, v in terms of t, where v is equal to a omega cos omega t, while when v in terms of y, okay, we do have v equal to plus minus omega square root a squared minus y squared. Alright, so in this case, we will use the second equation because we want to find what is the speed of the mass when the displacement is 6 centimeter, when y is equal to 0.06 meter. Okay, so therefore, v is equal to, okay, we can substitute omega 3.696 square root, the amplitude is 0.12 squared, and y is 0.06 squared. And straightly, we can get the answer, 0.384 meter per second. Okay, so this is the answer. Okay, the third one, we want to calculate what is the kinetic energy and the potential energy of the system when the displacement is 6 centimeter. Okay, we can straightly substitute in the equations. Okay, we have equation of kinetic energy and also the equation of the potential energy, where k is equal to half m omega squared a squared minus y squared, and u is equal to half m omega squared y squared. Okay, so we can straightly substitute all the values. So we have m, the mass, omega, and we have amplitude, and also y, which is 0.06. And finally, the kinetic energy, remember the unit, 3.69 exponent negative 3 joule. Okay, same goes to this one. You can straightly substitute m, 0.05, omega, and y, and straightly you will get 1.23 exponent negative 3 joule. Okay, make sure you write the correct answer with the unit. Okay, so the last one, we want to calculate the total energy of the system. So from the previous questions, so we have calculated the kinetic energy of the system and also the potential energy of the system. And this part, we can straightly find the total energy, actually kinetic energy plus the potential energy. Okay, so we have 3.69 exponent negative 3 plus u is 1.23 times exponent negative 3 joule. And you can straightly get 4.92 times 10 power of negative 3 joule. Okay, so this is the answer. Or, okay, so if you want to use the equation of the total energy of the system, yes, you can try to use that equation. Okay, where E is equal to half m omega squared a squared. So when you substitute all the values, then the answer is equal to sama 4.92 times 10 power of negative 3 joule. Okay, so you can choose either you want to straightly or total up this value of kinetic energy and the potential energy, or you want to use this equation. Okay, alright, so now on part B, Okay, on part B, we want to sketch the graph. Okay, so 8B, on the same graph, sketch and label both kinetic energy and the potential energy versus the displacement for the system in the question 8A. Okay, let's say we have this one. Okay, and this way. This way. Okay. Okay, you can label all the axes. So we have E in joule, and this one Y is in meter. So this one is 0, and this is negative A, and here let's say this is positive A. I will adjust a little bit. Okay. So remember, okay, please always remember. Okay, remember at Y equal to positive or negative A, the kinetic energy is equal to 0. Okay, when kinetic energy is 0, okay, the potential energy, okay, at positive negative A is maximum. Okay, but at Y is equal to 0, kinetic energy is maximum, but the potential energy is equal to 0. Okay, so now let's sketch the graph. So we know that, okay, for the kinetic energy first, okay, at positive and negative A, kinetic energy is equal to 0. So here and here. But at Y is equal to 0, the kinetic energy is maximum. So here on this axis, okay, and the kinetic energy, how about the value? Okay, when kinetic energy is maximum, kita dah kira tadi, okay, at Y is equal to 0. So remember, K is equal to half m omega squared A squared minus Y squared. Okay, so you can see here, when Y is equal to 0, then K is equal to half m omega squared A squared. And this is actually the equation of total energy. Okay, this is the equation, okay, equation of total energy, and this is also equation of potential energy U when Y is equal to positive negative A. Okay, so we can sketch the graph. Okay, and for the second color, I will choose this one. Okay, purple. Okay, so now remember, okay, for U is 0 when Y is equal to 0. Okay, here. And U is maximum value when Y is equal to positive negative A, where U is maximum at Y is equal to positive negative A, okay, and U maximum is equal to half. It's actually the same equation as m omega squared A squared. Okay, Y sini, Y yang dekat sini kita gantikan dengan A. Okay, so you can see this equation. Sebenarnya dia adalah apa? Dia adalah value yang sama. Okay, on the same line, on the same axis. So here also we're gonna have silap, terbalik. Okay, so here we're gonna have in this point, and here we have this point. Okay, so for the purple color, so this is graph of U. Allah. Okay, potential energies. Okay, so this is U, and here we have kinetic energy. Okay, so from the previous calculation, since we know that this equation, these two equation is actually the equation of the total energy. So this is actually the equation of the total energy. E is equal to half m omega squared A squared. So therefore, So we can write the value of the equation. So therefore, we can write the value of the maximum kinetic energy, okay, is equal to, this one is actually 4 point, so here E is equal to 4.92 times 10 power of negative 3 joule, okay. And you can also write this value of the amplitude, since we know that the amplitude is equal to 0.12 here, and here is negative 0.12, okay. So labelkan lah, alright. Make sure you label the value of E and also the graph, okay. So the purple color is for the potential energy graph and the red color is for the kinetic energy, okay. So let's proceed to question number 9A. Okay, question number 9, we have the vertical position y of a particle along x-axis under a periodic vibration is described by the equation of y is equal to 0.3 sine. Okay, so we have pi here, t over 3 plus 4x. Okay, so make sure you look at the equation carefully, because y is equal to 0.3 sine pi t over 3 plus 4 pi x. So when we try to compare with the general equation, y is equal to a sine omega t plus kx, okay. So from here you can see that omega is equal to pi over t and k is equal to 4 pi. Okay, we can write here omega is equal to pi over 3, alright, where pi over 3 radian per second, okay, and k is equal to 4 pi meter per meter, okay. So the first question, okay, calculate the period and the wavelength, okay. So since we know that omega is equal to 2 pi over t, then here we can straightly find t is equal to 2 pi over omega, where 2 pi over 3. Okay, so cancel. So this should be 6 seconds. Okay, so for the second part, we want to find the wavelength. Okay, so wavelength, as we know that k is equal to 2 pi over lambda. Alright, therefore, lambda is equal to 2 pi over k, where it's 2 pi over 4 pi. So we can cancel. So it's equal to 0.5 meter. Okay, finish the first part. Second, we want to calculate what is the vibrational velocity of the particle at x equal to 0.6 meter when t is equal to 3 seconds. Okay, so given that x is equal to 0.6 meter and t is equal to 3 seconds. Okay, so before we start, since the equation is the vertical position equation y, so we need to differentiate this equation and come up with another equation, which is the equation of the vibrational velocity of the particle. Okay, so let's try to differentiate the equation of y. Okay, so when we try to differentiate, so v is equal to dy over dt, where this is ddt. Okay, so y is equal to 0.3 sine 0.3 sine pi over 3t. Is it? Yes. Plus 4 pi x. Okay, so this should be the bracket. Therefore, v is equal to, differentiate sine, so it will become cos. Okay, so it should be 0.3 cos pi over 3t plus 4 pi x. So we need to differentiate again Okay, everything inside the bracket. So d over d dt, d over dt, to differentiate pi t over 3 plus 4 pi x. Okay, so differentiate respect to t. So this one should be pi over 3 here. Okay, okay, so we can write 0.3 times pi over 3 cos pi over 3t plus 4 pi x. Okay, so please check. Okay, how about your differentiation process? Okay, all right. So 0.3 times pi over 3. So 0.3 divide 3, it's 0.1. So 0.1 pi cos, okay, pi over 3. So at t is equal to 3 seconds. So we can straightly substitute 3 plus 4 pi and x is equal to 0.6. Okay, so yeah, you can try to use your calculator and make sure your calculator is in radian mode. Okay, in radian mode, not in degree. So 0.1 pi, so here we will get negative 0.30902 and the answer is V, negative 0.097 meter per second. Alright, okay. And the last one, we want to calculate what is the wave of the propagation velocity. Okay, calculate the wave velocity. Okay, so number 3, when you want to find what is the wave velocity, so it's equal to V equal to F lambda. So this is the equation. So we can substitute F, where F is the frequency. So how to find the frequency? Okay, remember we do have the value of omega. So omega is equal to 2 pi f and f is equal to omega over 2 pi, where omega is equal to pi over 3 over 2 pi and the frequency is equal to 1 over 6 hertz. Okay, so you can straightly substitute here. Frequency is equal to 1 over 6 and the lambda is equal to 0.5. Therefore, V is equal to 0.083 meter per second. Okay, so finish question 9A. So 9B. So 9B is very simple. Okay, so question 9B. So a wave of amplitude 0.3 meter interferes with a second wave of amplitude 0.2 meter. Means that we have the first wave. Is 0.3 meter and the amplitude of the second wave is 0.2 meter. Okay, and it's traveling in the same direction. Calculate the maximum and minimum resultant amplitudes that can occur. Okay, so now we want to calculate the maximum and the minimum resultant amplitude. Okay, so so let's say for the first one, we want to find the maximum amplitude. So, okay, it should be this direction. Okay, we have the first wave and then we also have the second wave. Why is it like this? Okay, so let's say this is the amplitude 0.3 meter and here is 0.2 meter. And the maximum resultant amplitude should be, so A maximum should be A1 plus A2. So it's equal to 0.5 meter. Okay. And how about the minimum resultant? Okay, so the minimum resultant or the minimum amplitude okay, so the minimum one, it should be okay, A1 plus negative A2. So 0.3 plus negative 0.2. So it's equal to 0.1 meter. So this is the smaller amplitude compared to this one. Okay, all right. So here we just have 2 marks. Okay, so 1 marks each. So the answer is 0.5 meter and then 0.1 meter. Okay, all right. So C, question number C. Okay, so 9C, we have the first overtone frequency of an air column in an open pipe is 440 Hz. So this case, we have open pipe. Okay. So open pipe. So remember, for the open pipe, so we have the fundamental mode, and we also can call it as the first harmonic. Okay, and if for the first overtone, OVT is stand for overtone, it's equal to the second harmonics. Okay, and remember, the fundamental mode or the pattern of the first harmonic for the open pipe. Okay, this is the open pipe, and the fundamental mode pattern is the X shape. Saya panggil dia sebagai X shape. Okay, so this one like this. 1, 2. So it's a X shape. Okay, so this one is for the first harmonic or fundamental mode. So how about the pattern of the wave? Okay, so how about the pattern of the standing wave for the first overtone and second harmonics? So for the first overtone, remember it's equal to second harmonics. So awak kena lukis 2 kali X shape. So look here, we have the first X shape, 1 and 2. Okay, okay, here we have 1. Okay, the first X shape and the second X shape. Okay, so let's proceed to the first question of 9C1. Given the speed of the sound, okay, so before that, given that the first overtone frequency, okay, the first overtone frequency is for the second harmonic, F2, is 440 Hz. And given that V is 340 meter per second. Okay, so calculate the length of the air column. So we want to calculate what is the length of the air column. L. Okay, what is L? Okay, so I have 2 methods here. You can choose which one that easier for you to follow. Okay, so method 1. Okay, so for the method 1, so I straightly use the equation of the open pipe. Kalau you ingat the equation, you confident about the equation of the open pipe. So Fn is equal to Nv over 2L. Okay, so here is Nv over 2L. Okay, so now you can straightly find what is L. Okay, look at here. So now, since F2 is equal to second harmonic, so N is equal to 2, so V is given 340 to L. So here we can find L, where L is equal to 234 over 2, and F2 is 440. Okay, okay, you can straightly find the length of the air column. So you can straightly find the length of the air column is equal to 0.773 meter. Okay, otherwise you can use for the second method. Kalau you confused, ni equation yang mana? Open pipe or closed pipe? Okay, you can try to draw the pattern. Okay, the pattern of the open pipe for the second harmonic. So this is for the second harmonics. So 2 kali X, 1, 2. Okay, so this is the length L. And you can see here, okay, the length here. Okay, so this is the half lambda, and this is another half. Okay, therefore you can write L is equal to lambda. Maknanya tadi adalah half lambda plus another half lambda. Okay, so L is equal to lambda. Therefore, we want to find what is L. Okay, you can find what is lambda. So V is equal to F lambda. Therefore, lambda is equal to V over F, where V is equal to 340. And the frequency, sebab kita tengah cerita pasal second harmonics, so frequency here should be for the second harmonics, 440. Okay, therefore, lambda is equal to 0.773 meter. And lastly, since lambda is equal to L, and L is equal to 0.773 meter. Okay, so finish C1. And sketch the standing wave pattern in the pipe indicating the position of the nodes and antinodes. Okay, dia tak bagi tahu dia nak first harmonic ke, second harmonics ke, third harmonics ke. Okay, so since the equation give us the frequency for the first overtone ataupun second harmonic, okay, in order to draw the pattern of the wave, so I use second harmonics. Okay, dua kali tadilah, 1 and 2. Okay, so here is antinode, node, antinode, node, and here is antinode. Okay, so finish. Okay, so for the 9D, we have the tension in a 50 centimeter guitar string of mass is given, and the tension of the guitar string is given. Okay, so take out all the informations from the question. So we have the mass of the string 0.5 times 10 power of negative 3 kg, and the length of the string is 0.5 meter, and the tension is 80 Newton. Okay, so ada lagi? Okay, tak ada. Okay, the first question. Calculate the velocity of the transverse wave on the string. Okay, transverse wave on the string. The only equation is V is equal to square root T over mu. Okay, so you can straightly substitute the equation, okay, with the information that we have. So it's equal to square root tension is 80 Newton. And how about mu? What is mu? Okay, so remember that mu is equal to mass per unit length. So given that the mass of the string is 0.5 and, the mass of the spring is given 0.5 exponent negative 3, and the length of the string is given as 0.5. Therefore, mu is equal to 1 times 10 power of negative 3 kg per meter. Okay, make sure you change to kg first for the mass, and length is in meter. Okay, so now we can straightly substitute here. Okay, mu is equal to 1 times 10 power of negative 3, and finally V is equal to 282.84 meter per second. So this is the velocity, okay, the velocity of the transverse wave on the string. Okay, for the second part, we want to calculate what is the fundamental frequency and its first overtone frequency. Ada dua frequency you kena kira. Okay, so we have string. Okay, remember for string, we have fundamental mode, so it's equal to, okay, it's equal to first harmonics. Okay, F1. And for the first overtone, so it's equal to second harmonic. Okay, so first harmonic F1, second harmonic is F2. Okay, and what is the general equation for the fundamental pattern ataupun first harmonic for string? Saya panggil, kalau tadi kita ada X shape, so here we have N shape ataupun kita panggil dorayaki shape. So this is the fundamental pattern for the fundamental mode or for the first harmonic frequency. Okay, and for the second harmonic or for the first overtone pattern, so the pattern of the standing wave for the second harmonics and first overtone, so dia adalah dua kali dorayaki kita. 1, 2. Okay, kalau third harmonic 3 kali lah, kalau fourth harmonic 4 kali. Okay, so now we want to calculate the velocity, the fundamental frequency. So fundamental frequency is first harmonic. You can straightly use equation for the string. Kalau you confident, Fn is equal to Nv over 2L. Okay, you dah hafal dah. Okay, so F1 for the fundamental frequency ataupun first harmonic, it's F1. N is equal to 1. So V is given. V kita dah cari tadi kan? Okay, so V is equal to 282.84 and the length is 0.5. So you can find F1 is 282.84 Hertz. Okay. And how about F2? Pun you boleh kira terus. Where F2 is equal to 2, V is 282.84 over 2L. Can cancel 2. Therefore, F2 or the frequency of the second harmonics is 565. Okay, 565.68 Hertz. Okay, Hertz. Okay, so this is for the first method. Okay, kalau awak ingat equation. Okay, suddenly you tak ingat equation, you tertukar. This is equation for open pipe or closed pipe or standing wave for string. String ke open pipe ke closed pipe. Okay, so you can sketch your diagram. Okay, here. I use red color. So for the fundamental frequency, so we know that we have this pattern. Okay, and this is half lambda. Okay, half lambda. So here we can write L is equal to half lambda. Okay, and therefore lambda is equal to 2L. Okay, so now you can find, so since you know that V is equal to F lambda, okay, finally you can find, okay, F1 is equal to V over lambda. Okay, so ini kita pasal first harmonic. So pattern dia pun adalah pattern first harmonic ataupun fundamental mode. Okay, so V over 2L. So V is 282.84 and the length of the string is 0.5. Sama. Okay, jawapan you akan dapat sama. So jawapan you akan dapat 282.84 Hertz. Ataupun you nak lukis for the second harmonics, so 2 kali 1, 2. Okay, so L here you can see is equal to lambda. Therefore, F2 is V over lambda and straightly V over L. So it's equal to 282.84 over the length is 0.5. Therefore, F2 is equal to 565.68 Hertz. Okay, that's all for question number 9. Alright, question number 10. So we have a metal wire where the length of the wire is 75 centimeter. Okay, so the initial length is 75 centimeter. And the diameter of the wire is 0.13 centimeter. 0.13 centimeter. So we can straightly calculate the radius. Okay, So the radius is equal to d over 2, and if you change to meter, so it's 0.065 times 10 power of negative 2. Okay, but we just stay in centimeter first. Okay. So now the metal wire is stretched, okay, to a length of 75.035 centimeter. Means that, okay, so this is the length initial and this is the length final. Okay, 75.035 centimeter. Okay, and when we have a load of mass given 8 kg, so here we can see here we have the weight is downward. So we can see here we have a weight is downward where W is equal to mg. So when we put a weight on the wire, so what happened? We actually put a tension to a wire. Alright, so bila kita ada berat, kita letak pada tali ni, pada wire ini. Okay, so means that we put an amount of tension on the wire. Okay, alright, so T is upward. Okay, so now we want to calculate the Young modulus of the wire. Alright, so the equation to calculate the Young modulus, Y is equal to F L0 over AE. Alright, so F here, okay, you can see, so this is the amount of force that we put on the wire. Maknanya, apa dia? Merujuk kepada siapa? Okay, F here, amount of force, iaitu weight lah. Amount of force, which is weight, that we put on the wire. Okay, and how about the area? Okay, the cross-sectional area of the wire. So A here is equal to pi r squared. So we need to calculate first what is A. Okay, so now let's change all the values into SI unit. So pi and r is 0.065 times 10 power of negative 2 because in meter. Okay, and squared. Okay, pi r squared. Therefore, area is equal to 1.3273 times 10 power of negative 6 meters squared. Okay, so now we can find the Young modulus is equal to the force F here is mg L0 over A. And how about the elongation E? Okay, where E is equal to L final minus L initial. So it will equal to mg L0 over A L final minus L initial. Okay, so we can straightly substitute where the mass is 8 times 9.81 and L0 is 0.75 meter over, and the area, okay, so 1.3273 exponent negative 6 times the elongation, okay, L final minus L initial, okay, it's equal to 0.035 centimeter. Make sure you change to meter. It's 0.035 times 10 power of negative 2. Okay, and finally the answer is equal to 1.266 times 10 power of 11 Newton per meter squared. Okay, so this is the answer. Okay, so second part, we want to find the strain energy. So this is very simple. Okay, so B, we want to calculate the strain energy. U is equal to half Fe. Okay, where F is the amount of weight that we put on the wire. So mg, and E is the elongation. Okay, we can straightly substitute. The value of mass is 8 times 9.81 and the elongation is 0.035 times 10 power of negative 2, and it's equal to 0.0137 joule. Okay, so finish question number 10. Okay, question 11a. So we have a glass slab has a surface area 1600 centimeter squared. So A is equal to 1600 centimeter squared. So this one if we change to meter squared, okay, remember how to change. Okay, jangan buat silap. 1600 centimeter squared times, so here we have centimeter squared and meter squared. So ini semua kena 1 meter is 100 centimeter. Okay, semua kena squared lah. Okay, so you can cancel this, and 1600 divide 100 squared, it's 0.16 meter squared. Okay, and given that the thickness of the glass slab is 5 millimeter, so given that dx is equal to 5 millimeter, milli is negative 3 meter. Okay, so let's say the diagram is like this. So let's say this is the glass slab. Okay, something like that. So the temperature, so this is the thickness, dx. Okay, so given that the temperature on the either side of the glass surface are 21 and 32 degrees Celsius. Okay, so let's say here is 32. Okay, so let's say here is 32 degrees Celsius and here is 21 degrees Celsius here. Okay. Okay, so now we want to calculate what is the rate of energy transferred. Okay, so the rate of the energy transfer is dq over dt. So we can straightly calculate. So now before we start, look at to the temperature. So the higher temperature is the initial T and this is the final T, because heat will be transferred from the higher temperature to the lower temperature. Okay, so in this direction of transfer. Okay, so now we can write T final is equal to 21 degrees Celsius and T initial is equal to 32 degrees Celsius. Okay, so dq over dt is equal to negative Ka dt over dx, where dx is the thickness. Okay, so the change of the temperature dt over dx. So T final minus T initial, 21 minus 32 over dx is 5 times 10 power of negative 3. And then dq over dt is equal to dq over dt. Okay, 295.68 joule per second. Okay, question B. Okay, question 11B. So we have the diameter of a hole in a steel plate is 1.35 centimeter. Okay, so let's say we have a steel plate here. Okay, so given that the diameter of the hole is equal to 1.35 centimeter and the temperature here is 25 degrees Celsius. So given that the coefficient of thermal expansion alpha is 1.2 times 10 power of negative 5 per Kelvin, calculate the cross-sectional area of the hole when the temperature of the plate is increased to T final is 175 degrees Celsius. So we want to calculate what is the cross-sectional area of the hole. Okay, so cross-sectional area of the hole. Okay, A is pi r squared. Okay, so we want to find A, where A is the final cross-sectional area of the hole. And we can straightly use this equation, where A is equal to, okay, remember, A naught 1 plus beta delta T. Okay, and you must know that the question gives you alpha, where beta is equal to 2 alpha. We have the expansion of area of the hole. Okay, so we can straightly use this equation. Alright, but before we start, we need to calculate what is the initial area, A0. Alright, okay, so we can calculate A0, where A0 is equal to pi R0 squared. Okay, R0 is the initial R. Okay, so soalan bagi diameter, you divide tu, you dapat R, where it's equal to, okay, so diameter is 1.35 centimeter, divide 2, and jangan lupa square. Okay, so A0 is equal to 1.43 times 10 power of negative 4 meter squared. Okay, so now you can find A final, where A final is equal to A initial 1.43 times 10 power of negative 4 times 1 plus beta is 2 alpha. Okay, so here 1 plus beta 2 times alpha, where alpha is 1.2 times 10 power of negative 5, and times the change of the temperature, final temperature minus initial temperature. Okay, therefore, okay, make sure you use your calculator carefully. Okay, press your calculator carefully, and the final answer must write with the correct unit, which is 1.435 times 10 power of negative 4 meter squared. Okay, so this is the answer. Okay, so now finish question 11. Let's proceed to question number 12. Okay, question number 12. So we have the temperature in outer space is about 3.5 Kelvin. So T is equal to 3.5 Kelvin. And it is estimated that there is about 1 hydrogen molecule per centimeter cube. And given that the mass of the hydrogen molecule, so the mass of hydrogen is 3.346 times exponent negative 27 kg. Okay, so now we want to calculate what is the RMS speed or VRMS of the hydrogen molecules. Okay, so as we have VRMS is equal to, kita ada temperature and mass, square root 3 kT over mass. Okay, this one we can straightly calculate 3, okay, 1.38 times 10 power of negative 23, 3.5, and mass is 3.346 exponent negative 27. Okay, and the answer is 208.1 meter per second. Okay, and B, what is the pressure of the hydrogen gas at the outer space? Okay, we want to find what is the pressure. Okay, so as we have the mass and also the volume is 1 hydrogen molecule per centimeter cube, actually we can straightly find what is the pressure. Okay, so apa formula pressure? So P is equal to 1 over 3 times density times VRMS squared. Okay, sebab kita dah ada VRMS from the previous question. But now we want to find what is the density. Okay, where the density is equal to mass over volume. Okay, so remember, so the volume here is 1 hydrogen molecule per centimeter cube. Okay, so means that the volume is 1 centimeter cube. Okay, so V is 1 centimeter cube, change to meter cube. So mass is given 3.346 times 10 power of negative 27, divide 1 times 10 power of negative 6 meter cube. Okay, jangan tak tahu macam mana nak kira. Okay, so this one saya tunjuk lagi sekali how to change. So this is from chapter 1. So 1 centimeter cube, okay, so centimeter, meter. 1 meter is 100 centimeter. So we want to cancel centimeter cube, so we need to take this. Mesti semua cube kan. Okay, kuasa 3 kan dia. Okay, so you akan dapat 1 times 10 power of negative 6 meter cube. Okay, so you can substitute here. And then the density you will get 3.346 exponent negative 21 kg per meter cube. Okay, alright, so now let's solve for the pressure. It's equal to 1 over 3 and density 3.346 exponent negative 6 squared. Alright, so now let's calculate the pressure. So P is equal to 1 over 3, where the density is 3.346 exponent negative 21, and the VRMS is 208.1 squared. Okay, and finally, the pressure of hydrogen gas at the outer space is equal to 4.83 times 10 power of negative 17, unit jangan lupa Pascal. And C, okay, question C, we want to find what is the translational kinetic energy of the hydrogen molecules. So KTR is equal to 3 over 2 KT, and we can straightly substitute the temperature is 3.5 Kelvin. So K is 1.38 times 10 power of negative 23. Okay, and temperature is 3.5. Alright, so finally the translational kinetic energy is equal to 7.245 exponent negative 23 joule. Okay, so finish question number 12. Alright, so now let's proceed to the last question. Okay, question number 13, we have a series of thermodynamic process ABC, and during the process ABC, so given that 120 joule of heat and 500 joule of heat are added respectively. Okay, so before we start, so now look at to the process. So let's say we have process A to B. Okay, you can look at here from A to B. So this is the volume. So we know that from A to B, the process happened in a constant volume. Okay, so when we look at to the process A to B, okay, we know that from A to B, the volume here is constant. Therefore, the process A to B is the isochoric process. Okay, so isochoric process, which is constant volume. Okay, so given that from the question, we know that for AB, so we have 120 joule of heat added to the system, and for BC, it's given 500 joule. Okay, you can see here this value is the positive value because heat is added to the system. Okay, if heat is released from the system, so Q is negative value. Alright, okay, so now let's proceed to this process A to B. So we know that in isochoric process, V is constant. Therefore, W is equal to P delta V. So V final minus V initial, it's equal to 0. Okay, so W is equal to 0 joule here. Alright, therefore, from first law of thermodynamic equation, okay, so Q is equal to delta U plus W. Okay, so now since W is equal to 0, therefore delta U equal to Q, which is delta U is equal to 120 joule. Okay, so the questions asks us to find what is the change in the internal energy in the process ABC. So you want to find the delta U for ABC. That's mean you want to find the total change in the internal energy for process A to B plus delta U B to C. Okay, so this is our objective. Alright, So we want to find delta U AB. So here is the delta U for AB, because just now we talk about the process from A to B. It's a isochoric process. So kita dah dapat yang first. Okay. So now look at the process from B to C. Okay, you can see here from B to C, the process happened in constant pressure, where the pressure from B to C is constant at 7 times 10 power of 4 Newton per meter squared. Okay, so look at the pressure. Okay, we have a constant pressure here. So this process, we call it as isobaric process. Okay, so because we have constant pressure. So for the isobaric process, we have two types of isobaric process, which are expansion and compression. So you can see here, from B to C, B, the volume of B is 3 exponent negative 3. Okay, but C is 6 times exponent negative 3. So you can see here, the volume is increasing, means that this is the isobaric process, but expansion. Okay, expansion process. So kita boleh letaklah kat sini. So isobaric process, and this is expansion, not compression. Sebab dah tengok pada arrow dia ya. Arrow dia from B to C. So you can see from B to C, then you can see here the volume is increasing. So it's expansion process. So for the expansion process, we know that Q is equal to delta U plus W from first law of thermodynamics. And we also can find W, P delta V. And it's equal to P is 7 times 10 power of 4. Okay, and times the change of the volume from 3 to 6 exponent negative 3. So kita boleh kira, tolakkanlah V final minus V initial. Okay, so sekarang kita cari dulu what is the W first. And then the W is equal to, the work is equal to 210 joule. Okay, so now we can straightly calculate what is the delta U from B to C, which is BC, and it's equal to QBC minus the work BC. Okay, BC. And QBC is given. Look at here, we have QBC is 500 joule, and 500 minus the work done, okay, 210 joule. Okay, so delta UBC 500 minus 210, it's equal to 290 joule. Therefore, okay, we can straightly calculate delta UBC is delta UAB 120 joule plus delta UBC 290 joule, and the answer is equal to 410 joule. Okay, so ini jawapan kita. Okay, so finish 13A. Okay, so question 13B. So we have a leak-proof thermos full with hot coffee is shaken vigorously. Explain what will happen to the temperature of the coffee. Okay, so now let's take out all the information given from the question. The first one. Okay, so what is the mean by leak-proof thermos? Okay, apa perkataan leak-proof ni? Maksudnya thermos tu di cover dengan insulator. Okay, so means that this thermos is insulated from its surrounding. Okay, so no heat transfer to the surrounding, means that delta Q is equal to 0. Okay. Second, okay, look at to the question. The coffee, the hot coffee is shaken vigorously. Okay, means that the work has been done on the system. Okay, kita goncangkan coffee tu. Okay, so work has been done on the system. Okay, so saya tulis kat sini, vigorously shaken. So means that work has been done on the system. Okay? Okay, from the first law of thermodynamic equation, we have Q. So we have Q is equal to delta U minus W. Why I put minus? Because here we can see that work done on the system, okay, done on it. Okay, so work done on it, so we take that W is negative. Therefore, here is 0. So delta U is equal to W. Okay, so now from here you can see that, okay, delta U is equal to W. So according to the first law of thermodynamics, the internal energy the internal energy of the coffee, okay, so will be increased. Okay, so you can see that the internal energy of the coffee will be increased since U is directly proportional with T. Okay, kena ingat. Okay, saya rasa awak tahu equation of U. So U is directly proportional with the temperature, where U is equal to F over 2 nRT. So U is directly proportional with T. So from this question, we can say that the internal energy of the system or the internal energy of the coffee will be increased since U is directly proportional with T. Therefore, the temperature will be increased. Okay, so this is the answer. Okay, so the temperature will be increased. So you can see that delta U is equal to W. So kalau kita goncang lagi, kita goncang coffee tu lagi kuat. So what happened? The work done on the system will increase. Okay, so when W is increased, delta U also increase. So when the delta U is increased, so tengok kat sini, delta U is directly proportional with T. So when the delta U is increasing, okay, so means that the temperature of the coffee also increase. Okay, so the temperature also increase. Okay, yang ni kenapa increase tadi? Tengok balik soalan, kita kata dia apa? Okay, vigorously shaken. Okay, so when W is increased, delta U increase, and delta U is directly proportional with temperature. Therefore, the temperature will be increased. So now we have finished discuss all the questions in set 3. Okay, so see you in the next session and make sure you buat jadual, you study and go through all the questions and make sure you understand all the concepts. Okay, jangan hafal jawapan, buat latihan, jangan baca soalan dan baca jawapan, tapi awak kena duduk dan buat dan tulis sendiri. Okay, Assalamualaikum dan selamat sejahtera.